All right, today, guys, I'm here with Esteban, and we're going over a really cool project that he started called ToolFront. I don't know if you want to give an introduction about yourself or anything, what the project is, before we kind of get into it.
Yeah, happy to. As you already heard, I'm Esteban. I've been working in ToolFront for a little bit less than half a year. To put it very simple, ToolFront is a library, a framework that we envision is the missing link between AI, agents, LLMs, and big data. Particularly, what we're trying to accomplish here is connect, the very complex and intriguing world of LLMs and, agents taking actions and retrieving data with, the complex, highly dimensional universe of data, large warehouses, large databases and such. I come from academia, a little bit about my background actually. Come from academia. I used to be a PhD in artificial intelligence before I dropped out to pursue a couple of ventures, and this is one of them.
Oh, nice. That's really interesting because I have a friend who is a biology major, PhD student who's almost finished, and I was meeting with him talking about how he's using AI. One of the things I noticed is he has things he wants to do mainly around spreadsheets and some other database types, but he doesn't really understand databases. So something like this could be really useful.
So the way I see LMs, and this is something I've been preaching for a while, LMs are an interface between people, right, and language. But language can be many things, right? Like language can be the internet. Language can be a book. Language can be an API. Language can be terabytes and terabytes of data in a very obscure warehouse. Language is math. Language is almost anything, right? Like anything can be expressed in terms of formula in many ways. So the way I see LMs in many, like one way that I see them, one of the main value adds in my opinion is as this high level interface to low level languages, right? Like if you want to write a SQL query, if you want to write code, assembly code, it's like some complex, sophisticated, if you want to speak some complex or sophisticated language, but maybe you're no expert in it. This is where LMs come in handy because they can act almost as a translation layer between natural language, the English language, language that we all speak, and these very low level sort of like machine languages. SQL, for example, being the one that we, at least currently, mostly focus on.
I completely agree. Well, I don't write SQL queries often enough, and whenever I do write certain ones, especially complicated ones, I always got to like reference all of these different things. But that's one of the best parts of LLMs. I love that I can just be like, what's this part of the syntax? Boom, get it.
Yeah, yeah. I mean, they do. Again, like they're very good at translation. That's actually where one of the original goals of LMs of transformers, the transformers architecture, was to translate languages, sentence to sentence translation. You grab a word or a sentence in English, you translate it to Spanish, or vice versa. And little by little, people started realizing that the opportunities for such a model were so much more than for just simple translation. So much so that nowadays, LMs are at the frontier of coding. We or society of people and companies and teams are able to build so much more, code so much faster than they were before, just with English in many ways, right? Like we all heard about the companies getting, more and more AI, and fewer and fewer engineers sometimes by the day, and it's speeding up a lot of development, and encoding, which is the language.
Yeah, and I love that one of the coolest parts for me is that if I know a couple languages really well, it's so easy also to just say, hey, show me how to do this in C or Python or whatever, and you just paste in your language that you understand, and now you start learning the syntax of another one.
Yeah, it's good for learning. I mean, at the end of the day, we're not strictly speaking language learners. Like we learn visually, we learn through all our senses. Language is not exactly a sense, but we perceive it. But it's very good for that. It's very I don't want to say customizable, but it can be tailored towards individual needs. And then the language that you are the most receptive to may be very different than the language I'm the most receptive to. And Allens are really good at picking that up because they've been trained essentially in all the internet and more a couple of times, so they're able to pick up on subtle patterns. They're able to pick up on, different speech patterns, different ways of expressing the same ideas. Of course, a lot of it comes from how you talk to them.
Yeah, for sure. Well, with that, let's get started. I'm trying to use ToolFront for a niche database, DuckDB, definitely niche. Not that many people seem to be using it yet, but it does seem to be growing. After that, let's try to talk about some of the exciting new updates that you're working on too. Yep. I think it could be nice for some of these database files that aren't connection strings that you actually need to mount to have like the full mount example. Could be helpful. But I'm sure most people are actually using Postgres and the other connections
That was
anyway.
original. DuckDB was sort of like a nice to have. It wasn't really your original sort of uh, goal.
Yeah.
Most, this project really started with us having a bunch of Postgres databases that we wanted to talk to, and then we realized, well, Postgres database, that's the tip of the iceberg. Then there's like entire warehouses. There's, for example, we're working with a benchmark that has about 15,000 tables, 15 terabytes of data, spread across God knows how many databases and such many tables. So a lot of the, oftentimes it's data scientists or researchers or data engineers or just about anybody who wants to interact with these vast amounts of data.
Hmm.
Not necessarily CSV files, not necessarily Excel files like DuckDB has,
Yeah,
though it
big.
would be definitely nice. Right? It's more like this massive warehouse where you sometimes don't even know what the data is. That's sort of like one half of the equation that we sought to solve, namely data discovery and search.
Hmm.
The other half is querying it. Once you know what you want to query, querying is a little easier. It's finding the data that's the hard piece. And if you'd like, I can show you perhaps how it works on my end with this big Snowflake warehouse that I mentioned.
Yes, that was exactly what I wanted to ask you next, because I'm really curious to see how it can help you find a lot of different types of data in these massive data sets.
Yeah, yeah. I mean, we could let's do that. Let me share my screen here. Um, let's see how to do this. Share screen. All right. Let me zoom in a little bit. I'm using cursor. Very similar to VS Code. It's similar layout.
That's what I usually use. Yeah.
Yeah, yeah. So we've already plugged in our MCP here. We have already kind of put in or like inserted, let's say, the full URL for a Snowflake warehouse. That's all it really takes. Like just one simple URL string for whatever warehouse or database or just about anything you need. And immediately, once the MCP is plugged into Cursor's agent, you can start asking it questions. So there's this, for example, one single table related to bike rides, the New York City bike rides to be precise. So it's like a big table that contains like the bike length, like the bike ride length, and the locations and such. So let's see, without giving you maybe more context, let's see how Cursor can now discover this table and query some information, like let's say the 5 longest bike rides in New York City. Find the 5 longest bike rides in New York City. Let's just clarify that it's in Snowflake. We're actually using Claude 4 Sonnet, which is a little bit of a slow model, but quite a smart model. And as you can see here, the first thing that, given the MCP, that any agent will do is discover the available data sources. This is the only one we've, plugged in. This is the obfuscated URL for like Snowflake warehouse. And as I mentioned before, that's really all we need. One URL, one string, and it'll figure out the rest. What it's doing now, following up, is searching across all the different tables. As I mentioned, there's about 15,000 tables to find ones that are somewhat relevant to the query task. Let me show you here. The first time you search tables, it's a little bit slow. The second time it's faster because it's caching the results. But for example, for those of you who are not familiar with BM25, BM25 is a slightly smarter, a slightly better TF-IDF, term frequency versus, I think, domain frequency search criterion, and it's finding table names that contain, bike ride New York City, city bike, strings or substrings of such. Here we can see here all the ranked tables. This information is
Yeah,
not really
that's
relevant
a
to us.
lot.
It's not really relevant to us. It's relevant to the agent. We're just
Yeah.
inspecting what the agent saw. And now what it's doing is it's inspecting the table or sampling a table, the table particularly that it thinks the answer exists in, and now we have the answer. And the interesting bit about this is that, if it gets, for example, this time we got the answer right on the first try. There's the actual, like, the longest bike ride is actually of over like 5,000 hours. But that's also because the bike got stolen, right? I know the answer to that. It's not very logical, but regardless, if the model gets the query wrong, and it often happens, right? SQL is a very hard language. Translating it from English to SQL, like translating it from English to SQL is hard, and oftentimes you'll see that the agent doesn't get it right at the first try or the second.
Yeah.
There's this built-in sort of like feedback loop by which it will retry again and again until it gets it right. And this retry is not just rewriting the SQL; it's a little bit smarter than that. It will inspect tables, like It will sample tables to observe its content. Inspection means just looking at the schema, like the column names, over and over again until it discovers and kind of like learns on the spot enough data to write the appropriate query. I'll just keep trying and trying and trying until it gets it right, or you tell it to stop, or it fails. But it hardly ever does it fail. It typically kind of keeps trying to figure it out. Does that make
Before
sense?
you move on, how are you able to like teach or show the model with some of these tool call responses that you want it to do certain actions? In the results I saw at the beginning, it was just like a strict array list of tables, for example. Are you
Yeah,
returning more information along with that hints at the model to do something?
that's a great question. We're not returning more information. The information itself is very raw. So, for example, the model searches for tables. The table is just a list of strings, a list of table names. Like they're not meant for humans. It's in a way speaking the language of LLMs. It's the data, like raw data that the LLM needs as feedback to continue its sort of like iterative approach to find the right data. Same thing happens with inspection. Like inspection just gives us an ugly CSV form. Like it's not even formatted in cursor. It doesn't matter. It just dumps like the schema for a table. To us, maybe it's not as interpretable. Unless we put it in like a nice Excel or something. To the LM, it makes a lot of sense. So much so that it thinks it's maybe the right table. They will sample it. Something similar will happen. You will get a couple of samples from that same table over and over again. Same thing with the query until it gets the right answer. And to answer your question regarding the instructions are elsewhere. The instructions are embedded in the MCP server. The instructions exist within sort of like the whole context of the MCP. And to maybe give you a little bit more detail about this, the MCP is really just a bundle of tools and a context, like an overarching context to give context or information to these tools whenever let's say an LM calls them. And a tool being just a function it can call. So for example, the context in this particular one case is this Snowflake warehouse URL and a bunch of instructions. The instructions are always the same, telling LLMs what is like a good approach to answering a user's query. And typically, a good approach involves the discovery process before even trying to write a query, which is what happened here. There's search, there's inspection, there's sampling, and then eventually there's a query. And maybe the query is wrong, so we'll try again. Does this answer your question?
Yes, it does. I have two more questions. One question, I know it does some of these samplings and other things, but how confident can you be that it ended up getting the right result? And do you have different tests for that? Like, is
That's
it 95% of the time it does get it correct after doing that, or what have you been seeing?
well, I cheated with this question because I know what the answer is. It's always easy to benchmark and evaluate models if you know what the answer is. Typically what people do is like a back like a quick calculation. They test it on 10 prompts or something, and give or take, if it works, it's fine. That doesn't scale typically. If you're building production systems, if you actually want to deploy a reliable system that, at least for the Snowflake warehouse that works well, God knows how well it will work in others, you need more robust evaluations and benchmarks. You need dozens, if not hundreds of samples for which you know the answer to and for which you can evaluate your model. That is actually something we sourced from a research paper called the Spider 2 benchmark paper, which contains over 300 questions and answers from this particular kind of Snowflake warehouse. This is actually one of the answers to one of the questions, which of course we know is right. So to maybe recap, if you're building production systems, if you want your systems to be reliable, you need to properly evaluate your models. And this involves dozens, if not hundreds, of data samples that you can test, the accuracy and correctness of your models on.
That makes sense. What specifically are you using to do these validation tests? I'm curious. I've been building an MCP at my work, and I've also seen a few tools for kind of evaluating different things. But I'm really curious, do you have some special open source project or something where you give it the question and the answer and run all of those all at once?
Sadly, no. I unfortunately have found that evaluations are very custom. So the evaluations for one model or let's call it
Yeah.
a machine learning problem, can be radically different than the evaluation and the setting and the setups for another machine learning problem. We are particularly taking a somewhat vertical, somewhat niche problem, which is question answering, or from databases, and now APIs, and now documents, soon enough. Evaluating these types of models, evaluating these types of agents is very different than evaluating, say, a chatbot for a, I don't know, like some website or a Slack bot or something. So unfortunately, we don't have any open source library or project for this. It's all kind of custom built in-house.
So you actually have some sort of command line tool or something though that you can just run all of them and it just queries the model. I'm curious, how long does it take and how many validations do you run?
It's a little bit long, a little bit expensive, not gonna lie, because it's, about 200 and something data samples. And each data sample is like a full agent loop, meaning it's about 10 LLM calls or something, right? It's not cheap, but it's also not super expensive. What we typically do, since we iterate so fast, is that we take a subset of it, take like maybe 30 or so questions and do sort of this ad hoc analysis on them. We don't have like a very pretty command line. It's more rudimentary, I would say. We will eventually build something that's a lot more scalable, something that allows us perhaps to parallelize the benchmarking, to split or save some costs using like bulk requests to OpenAI or other LLMs. There's also the issue that, a big important issue I think in evals, that the evaluation results vary drastically depending on your LLM. So what may be a really good prompt or context or MCP for Claude may be very, very, very bad for OpenAI, or vice versa. So it's always important that this is where like complexity becomes exponential. It's very important to, for a project like ours, which is really LLM neutral. Like we don't provide an LLM. Like that's up to the users. You can choose your own LLM with Cursor or Copilot. You can build your own agents with this. It's important to be holistic and thorough and make sure that at least across the board, this is doing fairly well, because we may be quote unquote overfitting to Claude, or beautifully for Claude, but then it may just be terrible with, let's say, ChatGPT or 4.1 or something. So that's
Yeah, it sounds really awesome what you guys are able to do. I don't see that many open source projects that seem to evaluate the results as thoroughly as you guys are. So that's pretty cool. It also makes me think that there's definitely has to be some sort of evaluation suite that everyone starts using in the next few years. It's got to exist because every time there's a new model, like you said, it can be difficult. Maybe there's a regression, maybe your tool doesn't work as well, and then users blame you because they don't always understand all of that. It can be tough.
It's hard to standardize evaluations and benchmarks. Like, let me make a distinction between evaluations and benchmarks. Benchmarks are task specific. Evaluations are, well, I guess more model specific. Like a model, for example, coding benchmarks. The Spider 2 is a data warehouse SQL benchmark. Our product is evaluated on many benchmarks, or products, should be evaluated on many benchmarks. Every benchmark represents a particular niche use case. So, for example, somebody building a chatbot may want to evaluate it on a safety and security benchmark, or on a reasoning benchmark. Even LLMs themselves have their own list of benchmarks. So it's hard to standardize this whole thing. I think at the very end of the day, it's up to the creators, the developers, the builders, first of all, to evaluate things properly and to pick the right benchmarks to evaluate things on. And more often than not, sadly, there's no benchmarks. People build custom models, custom agents, custom systems or software all the time, and not always is there like a publicly available benchmark to ensure, its correctness or accuracy or compliance or any of like the benchmarkable metrics. Oftentimes, this is what sometimes sets apart, good companies from bad companies. The good companies build their own internal benchmarks and continuously improve upon them. They know they're making progress because their own internal benchmarks evaluations are getting better by the day. Other companies, especially startups, it's hard. They don't do this, and it's really a shot in the dark. Are your models getting better, or did it just so happen that OpenAI swapped some feature component in their model so it's sounding a little better? Is your product getting actually is it more accurate? Is it delivering more value, or does it just feel like it, or maybe not? Maybe not even feeling like it. It's a very hard question in the LM space.
Yeah, definitely. I almost meant more so like a standardized tooling for different languages to quickly set up benchmarks and evaluations. But yeah, everything else, it's definitely a very hard problem. One more question I had, how did you settle on the specific tools that you made for your MCP? I'm assuming you experimented with some different types of tools and different ways of doing it.
That is a great question, and that is the bulk of our work. The bulk of our work has not been connecting, LLMs to databases. That can be done in a day. The bulk of our work has not been to build the infrastructure and the ORM structure for our open source project that can also be done in a weekend. The bulk of our work has been precisely that, precisely figuring out the smallest, most relevant set of tools that gives any agent all the context and all the action